Often referred to as Earth's evil twin, Venus is a scorching inferno with surface temperatures hot enough to melt lead and atmospheric pressures crushing enough to crush submarines. But what if we could terraform this hellish world into a second Earth? Venus, the second planet from the Sun, is a world of extremes. Its thick atmosphere is composed primarily of carbon dioxide, with clouds of sulfuric acid shrouding its surface. Surface temperatures soar to a blistering 870 degrees Fahrenheit, 465 degrees Celsius, hot enough to melt lead, while atmospheric pressures are more than 90 times that of Earth's. Despite these challenges, Venus holds the potential for transformation into a habitable world. The Venusian atmosphere. The key to terraforming Venus lies in its atmosphere, which, while hostile to human life, contains the raw materials needed to create habitable conditions. By leveraging the abundance of carbon dioxide in the atmosphere, we can initiate a process known as carbon sequestration, where carbon dioxide is removed from the atmosphere and stored in solid or liquid form, effectively reducing the greenhouse effect and cooling the planet. Cooling Venus. Cooling Venus is the first step in making it habitable. By reducing the greenhouse effect caused by excess carbon dioxide in the atmosphere, we can lower surface temperatures to more moderate levels. This could be achieved through a variety of methods, including the deployment of giant sunshades or mirrors in orbit to block incoming sunlight, the introduction of reflective aerosols into the upper atmosphere to scatter sunlight back into space, and the use of space-based solar power to harness solar energy for cooling purposes. Atmospheric transformation. Once Venus has been cooled sufficiently, the next step is to transform its atmosphere into one that is breathable for humans. This could be achieved through a process known as terraforming by proxy, where genetically engineered microbes are introduced into the atmosphere to produce oxygen through photosynthesis. Over time, these microbes could gradually convert carbon dioxide into oxygen, creating a breathable atmosphere similar to Earth's. Shielding from solar radiation. As Venus's atmosphere becomes more Earth-like, the next challenge is to shield the planet from harmful solar radiation. Venus lacks a magnetic field like Earth's, which means it is vulnerable to the solar wind and cosmic radiation. To protect future inhabitants, we would need to deploy artificial magnetic shields or create underground habitats to shield against radiation exposure. Establishing habitats and infrastructure. With Venus's transformation well underway, the final step is to establish permanent habitats and infrastructure to support human colonization. Pressurized domes and underground habitats could provide shelter from the harsh surface conditions, while solar power plants and atmospheric processors could provide energy and resources for the growing population. Agricultural facilities could be established to grow food, and mining operations could extract valuable resources from Venus's surface. Conclusion and vision for the future. As we conclude our exploration of terraforming Venus, we are reminded of the transformative power of human ingenuity and determination. While the challenges of terraforming a planet may seem daunting, they are not insurmountable. By harnessing our collective knowledge, resources, and technology, we can turn the dream of a habitable Venus into a reality, opening up new frontiers for exploration, discovery, and the expansion of human civilization.